right. We have next an invited talk from Emanuele Frontoni. I first met Emanuele in InterPARES symposium in Abu Dhabi in February of this year. And his work was very interesting to me. So I wanted to have an opportunity to share this really interesting work with all of you. So just quickly to introduce you to Emanuele, he is a full professor in computer science with the University of Macerata and the co-director of the VRAI Vision Robotics and Artificial Intelligence Lab. His research interests include computer vision and artificial intelligence, no surprise there, with applications in robotics, video analysis, human behavior analysis, extended reality, and digital humanities. I'm not going to go on and on. The full bio is on the CAS website, and it's very impressive, other than to say that he was like the #2 cited researcher in the world, or which is like kind of incredible to even get your head around. So we are very thankful you have taken the time to join us today, Emanuele. And without further ado, I'm going to turn it over to you. Okay? Go ahead,
Thank
please.
you. Thank you, Vicky. Happy to be here and happy to see that you are in Sorrento with a good coffee on your hands, the good Italian food. I think that you are in a very beautiful place also before Christmas. So you are lucky than me that I'm still working in the north of Italy for a couple of days, and then I will be back for Christmas also. So I will also try to be quite fast given the long day that you had. And the goal of this speech, of this talk that we decided, and thanks again to Victoria, to Richard, and to Mark for inviting me here, is to tell you the old story of one of the study inside the InterPARES Trust AI project that is named PergaNet, telling you also what is the future view of this kind of study and where we are moving to. This future perspective, let's say the last 3-5 slides of my presentation, I think that are the more interesting also for future discussion that we can have together. Just a few words about my lab. I was really lucky to meet a lot of you. I see also Jessica here and a lot of people coming from the InterPARES Trust AI community. And in the last 3 years, we have done a lot of research in archival science, also discovering quite a lot of news and learning a lot about archival science, because I am a computer science guy working in AI with a very poor knowledge about this kind of field up to 3 years ago. And now in these young guys working in our lab, you can see also some of them that are coming from digital humanities and from archival science. Some of them, Alessandro in particular, is now in UBC, and we are going back and forward with the lab of Mohammed in UBC that is guiding together with Luciana the InterPARES project. And we are very happy about this new international project that is also helping our young guys to do a lot of new research together with us. So just a few words also about the schedule, the agenda of my presentation. I will tell you, as I was mentioning, the old story of my study, that is also the present one. But at the end, we will try to understand how we are moving from the usual AI to the generative AI with a lot of prompt-based approach that we are studying, just to give you an idea about what will be, according to us, and we are very happy to discuss about this in this workshop, the future research vision that we can adopt together. Everything starts from this presentation, and in a certain way, this idea of trusted data forever, is AI the answer? That was a great title invented for this paper, is also the guideline that is guiding the alliance between AI and archival science. I really think that this alliance, and I will come back to this paper also in the conclusions, is a great alliance, also to give a lot of value to archivals and to help a lot on a mutual kind of alliance. So in a certain way, AI is supporting a lot of research in the field of archival science, but also archival science can support a lot of new data sets and new way of doing research in the AI field. And this back and forward is crucial because we cannot work only to serve another field of research, but really we need to have a win-win solution for that. And if we look to archives, and also we are inside a very big conference about big data, probably the biggest one about big data inside the IEEE community. There was a paper, a quite famous paper of 2021. I just read the sentence. Long before big data as an idea had been invented, archives already measured their collection in kilometers of file and folders. That's why we tried together with the InterPARES community to run a small survey last year to try to understand how many data are collected and digitalized inside the public archives. And if you look here, where my mouse is moving, the National Archives of the US has 1,323 terabytes of data. That means that we can really trust a lot on this kind of data with a lot of metadata in the middle, also to try to understand and to test new AI methods on very new and novel archives that we usually in our field call datasets. And this idea of using archives as a novel way of using datasets, I think, is really another great point of work that we will discuss later on. Now, why we talk about appearance-based analysis on archival science? So one of the point here is that usually when we talk about archives, we imagine text or documents and things like that. But as you know better than me, we have a lot of archives with health images, EHR images, with a lot of metadata in the middle, with the big problems of anonymization and privacy, with a lot of work that has been done for annotation, for again designing metadata, and these are really helpful data sets for us. So starting from this point of view, we can imagine that working with things like that, where we have images in the middle, annotation in the middle, some text in the images, names, colors, different kinds of things, probably we need to have another way of thinking also in this kind of work. Then we met Tracy, another researcher and a professor, a colleague of us working in Carleton University in Canada. And she, during the InterPARES meetings, she was referring a lot about 3D models, digital twins, point clouds. And again, we have to preserve also these kind of contents and documents. And so we started again thinking that we can design some kind of approach that is also taking care about 3D point clouds, for example. Again, the idea is always to try to not leverage only on text. We are not saying that text is not relevant. It's the opposite way. We know that there is a lot of research about text, and also this afternoon I listened to some very nice research about that, but we have also a lot of images, like again what Jessica was mentioning before in her presentation. And then we arrived with another nice news for us coming from computer science. We collected a huge amount of ancient parchments that, as you can see from images, are very nice pictures with a lot of signs, with a lot of stamps or very, very small graphics around. There is some text around, but we are not taking care too much about the text because everyone studying diplomatic can understand several kind of things directly from the images. And have a look here. These are pieces of art. These are very famous pieces of art that are in the Archive of Milan, and this is another one. And we started going back to our experience. And in just something like 20 years ago, when I started my PhD in the ETH in Zurich, I wrote this paper that was titled Appearance-Based Robotics. So we started back and we go back in the history, trying to understand if we can reapply this idea of appearance-based. What I mean by appearance-based is a way of learning where we only take care about very evident and a very clear point that are totally far from a clear semantic. And going back to this idea of giving a semantic, this is a small picture designed by my third child, Giacomo. Giacomo is 5 years old, and now his way of learning appearance about soccer is this way. So we are learning appearance in a way that is very common also for computer vision, also for deep learning, and we discussed with one of the invited speakers of the afternoon on this kind of approach. So now the goal was, can we try to reuse this appearance-based approach for different kind of data, both point clouds, images coming from health diagnostics, ancient documents, and so on and so on. And this is the goal of PergaNet. That was the starting point of a new way of analyzing documents that is totally based on deep learning and is totally based on the research question of understanding shapes, signa, position of text, defects, missing parts, graphics, writing style, abbreviation, signature, notes, everything that is not based on OCR. So we don't want to pass by a text, but we want to stay on the appearance that we have inside this document. And with this mission, we started our research. We started our research discussing with archival scientists that told us the story of the Signa Tabellorium, that are data and images coming from a large number of parchments that are digitalized. You can see here some of these examples. This is a Signa, this is another one, and so on, another one. And all of them can be piece of information, piece of semantics that we can search for and then try to give this attribute to something else. And starting from this library of Signa, we try to design a catalog of these, trying to going back in a cooperation with a lot of archives in Italy, of state archives. And you can see here the matricula of the Milanese Notarium with a lot of Signa here where I moved my mouse. And again, we started collecting datasets. And this idea of collecting datasets inside the PergaNet study is another big point. Why that? Because when we started the dataset collection, we started designing the PergaNet framework. And the PergaNet framework is starting from there. As always, in every AI approach, we need to work on the data collection, data annotation, and dataset preparation. And every deep learning or generative AI solution that we want to design is starting from here. And that's why we started also using a system like the one that you are looking here. Is a very famous US-based company that is designing this Voxel 51 solution. Is quite common on computer vision, but is not so common on the world of archival science, to make this sort of small annotation that are really semantic annotation that we can have on the single image. And this idea of semantic annotation on single images is another good idea that we can leverage on for the future of dataset designing that we can have together. So now, moving forward on this idea, we designed the three different layers of semantic representation inside the deep learning pipeline of PergaNet. And this idea of semantic representation is based on a first neural network that is classifying recto and verso, and is a very simple solution. Then there is a text detection system, and then there is the Signa detection system. The Signa detection system is a semantic annotation that is based on the same concept that I was showing you in a few slides before. So starting from the first, it's something that I think is very, very common for those who are coming from the computer science and the AI field. Probably is not so common for the others, but this is a VGG16 neural network, very, very common in the state of the art. And we trained this on recto and verso classification. Then we try to move forward again and to understand if we can perform text detection. And this text detection, I don't know if it's really visible on your screen, but you can see some blue squares, some blue rectangles everywhere, and we can understand and analyze where there is some text or some graphics or any other semantic concept that we want to understand based on the deep learning approach that we have. And this idea of text detection was again taken from a pipeline of deep learning that is common in computer vision and deep learning approaches. You see here some results applied to parchments, and the idea is always, are we able to design a specialization of our methods for archival science and also for every kind of, let's say, multimedia data inside these archives? You can see here some more results, some others here. You see that the parchments are really strange. There is no one similar to the other. Everything is different. The text is everywhere. Text is vertical, is horizontal. There are holes. There are a lot of problems also in terms of quality of the paper that we are reading from. Third step is the signa detection. And the signa detection was based on annotation. And you see that these red squares are the one designed by the experts using voxel or any other semantic segmentation system that can allow to design a square on an image and to give a semantic to this area of the image. Is a metadata with some coordinates about pixel, nothing more. But this is very important also in terms of lesson learned that we had in the past. Here you can see the table with what we call notarial matricula notation. So we have different signa for different notaria, and everyone has a name with some historical information, and we try to design everything and to collect this kind of information and to train a system based on deep learning to do that. This exercise was quite nice because the results that we obtained were very, very good, and now we are able to process thousands and thousands of parchments totally in an automatic way, to give them metadata, to give them some other metadata, to let's say improve a lot the metadata that we have collected with these parchments. Now we are collecting also the facts or any other information that we are here. You can see here that now together with each prediction, we show also the confidence of the single prediction. And this small number is the confidence. And you see that sometimes you have a very complicated task, like having a signa here and another one inside the other. Okay. It's not really easy. It's not a very simple task. It's really, really different from having from the recto and verso. That is a very simple task for the computer vision. Here you can see another results. And now we move on to what is the future and what we are working on, because all the history of deep learning changed in the last 3 years, very, very, let's say, also dramatically in terms of speed, also for our research teams. It's full of opportunity, and now we are trying to stress what we can use and reuse about this concept of generative AI and prompt-based AI inside this experience of PergaNet. And we are now designing version 2. That is the idea that PergaNet is now moving to visual language models. Everyone is moving there in our field of research in the computer vision community. And so we are discussing with archival scientists on how we can move there. Can we design a specialized visual language model for appearance-based archival science task? This is the new research question. And if you look now, the schema in the slide probably is quite complicated, is a bit complicated, but the idea is to use Gen AI and the visual language model to move all our research on a prompt-based approach. And we started designing the first prototype of this. And with this idea of the first prototype, you can imagine some application. So let's see what we are trying to do. First of all, the prompt-based approach is something that for sure will change the way of using and approaching any kind of software designed with deep learning and some intelligent behavior. And so just have a look to this example. We can say, okay, please, PergaNet and version 2, detect signa, percentage of text, and estimated datation of the parchment. And we can upload the parchment, and then we can have the answer. The answer is the figure reports the signa detection results. Each notarium ID is reported in the attached table. Percentage of text is 73%. Estimated datation is AD 1330. Okay, this is the way of thinking. So what we are moving on is on the idea of having no more a system that is performing an analysis and giving us some answer, but like any other prompt-based approach for using novel methods, mainly based on transformer, if we go on the methodological aspects, we are trying to design several specialized visual language models that are using appearance-based and that can be used by a prompt. And this can be used by a prompt. I think that is something that is really interesting also for the usability of the system. If we trust that things like GPT-4 and every other large language model-based system will be the future of our way of interacting with the intelligent system. So the idea of discussing, performing, giving questions and obtaining answers is still, I think, one of the things that we have to work on. Now, just to go to the conclusion, and I don't want to use a lot of time on this task, but you know, and Vicky and all the Jessica, everyone that is working around InterPARES knows that we have a lot of discussion about AI ethics. And we tried also to have a PergaNet version 2 inside this idea of ethics by design. Every time we design a new piece of the pipeline of PergaNet version 2, we have this way of trustworthy AI application with all the compliance, both for privacy reasons and for AI ethics. What that means? First of all, we are using open source approaches that are more transparent than the others. And please be very, 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 let's say, ethic on the use also of this very big large language model from companies like OpenAI when we want to design something that is really ethics by design. You know that there is full of open source large language model, and we trust that we really think that this way of thinking based on open source is much more trustworthy and ethics than others. The second point is to try to design a framework, and we also founded a spin-off company of our university that is named Gaia, and that is there only to try to understand what is the correct framework for several applications like health, for example, or archival science. And with this novel framework, we try to design the compliance of every single piece of the pipeline that we are using. And then we have also to take care about biases that we have in our datasets. Even if it's parchments, we have to discuss about bias we have in these parchments. I don't need, I think, to discuss with you about health or other HR or other impressive things where we have to study a lot. So this slide is only telling you the story that now we are totally focusing on having ethics by design inside the pipeline of developing PergaNet version 2. Finally, my future view and the message for you. We are working a lot on applying this new version on health images 3D point clouds is the point of the beginning of my talk. And we think that this way of doing with appearance-based is really affordable for 3D contents and multimedia contents. To do that, we need to collect novel archival science datasets or novel archives that are very suitable for appearance-based test performance, test approaches, and benchmark. This idea of benchmarking, of having a collection of archives that are suitable for AI, I think is another point that we have to stress a lot. We want to keep privacy and ethics by design on the same level of technical developments. So if we want to reach a 5% more on accuracy, we want to reach a 5% more on accuracy with ethics by design in the middle. Finally, we want to improve this alliance between AI and archival science. And I think that this is the great message that is my takeover from InterPARES, and I think also is the message that I want to share with you, because computational archival science is really, I think, one of the core of this alliance. And if this alliance will be successful, both AI and archival science will have a win-win final solution. So thank you all for attending this presentation.